All right, we're going to go ahead and continue with some line integrals. We're just going to do some practice. So evaluate. The integral over the curve xy ds, where the curve here is given by, let's write it as this: x is t squared, y is 2t, and t is between 0 and 2. Okay, so first thing I'm going to do, I'm going to go ahead and write out what is ds. ds, remember, is the square root of, I'm just going to write it like x prime squared plus y prime squared, just in the interest of saving space, or saving writing for me, dt, because you don't want to kill trees, at least, or virtual ones even. Okay, so ds is going to be the square root of 2t, oops, 2t squared plus 2 squared dt. Okay, so what are we going to get? We're going to get the integral t goes from 0 to 2. Okay, x is t squared times y times the square root of, let me write that as 4t squared plus 4 with a dt on the end. Okay, we can do a little bit of simplifying here. Let's do that. So we have a 2 here in front. We have 4t squared and 4. So I can factor that out as a 4 inside the square root, which becomes a 2 outside the square root, right? So that's going to give me 4 t cubed times the square root of 1 plus t squared dt. Okay, so, how am I going to integrate this? Well, I'm going to integrate this with a substitution. Oh, that's going to be important. Let's not forget that. Let's move that over here. Okay, so that's going to equal. Let's do a u sub. Let's try to use a darker orange. Let's use red here. So my u is going to be 1 plus t squared. That means my du is going to be 2t dt. Okay. I'm just going to write down here t squared is going to be u minus 1. Why? Because really what I'm going to do here is this. I'm going to play this game. 4, this is still in t. I'm going to write this as t squared times the square root of 1 plus t squared times, and that other t went over here. Okay? It's just a matter of having done this sort of problem a few times. I know what I'm going to look at. So now, doing my substitution, 4. Now, the sub. When t equals 0, u equals 1. Okay, so if I plug 0 in here, I get 1 over here. Now, when t equals 2, oh, I love that. When t equals 2, I'm going to get 5 on my upper limit. Okay, t squared, we've already seen, is u minus 1. The square root of u, and then t dt is 1/2 of du. So let me put a 1/2 du. I'll write this as 2, the integral from 1 to 5. This is just simple. I can just distribute here, right? So I'm going to have u to the 3/2 minus u to the 1/2 du, and I'll trail that off because I figure everyone watching this video can calculate that integral. If not, then you need to go back and watch other videos. All right. Let's do another one. We've got some space. Oh, wow. We could really do another one. Let's do another one over here. So let's take the integral over a curve of x sine y ds, where our curve is the line segment from 0, 3 to 3, 7. Okay, so we could write that as, now, if I think about this as the line, it's got a y-intercept of 3 and a slope. It goes up 4 and over 3. So that would be 4/3, right? Up 4 from 3 to 7 and over 3. So I'm going to write this as t in x and then 4/3 t plus 3 in y. And t, I'm going to write it like this, goes from 0 to 3. Okay, and let's just double check that. Okay, so when t equals 0, what do I get? When t equals 0, I have 0 here, 3 here, just like what I needed. When t equals 3, what do I get? I have 3 here, and then the 3 here would cancel, and so I get 7. Okay, so this is correct. It's sometimes nice just to double check things. Okay, so this integral is going to be from 0 to 3 in t. Our x is t, and we're going to have the sine of y. Y is given by this expression. So we have 4/3 t plus 3. Okay. ds, remember, is the square root of x prime squared plus y prime squared in this case, because it's two-dimensional, dt. All right, let's simplify that a little bit. From 0 to 3, t sine of 4/3 t plus 3 square root. X prime is 1. Y prime is just 4/3. So, I don't know how to do math. 16 over 9, and then dt. Okay. How would you integrate that? Well, first thing you would do, probably make a substitution here. I would say let's let u... Actually, you know what? I wouldn't do that. I would do an integration by parts here. Okay, so to do integration by parts here, I would let u equal t, dv equal the sine of 4t plus 3 dt. Let me simplify this just a little bit first. Sorry. 1 plus 16 over 9 is 25 over 9, right? Square root of that is 5/3, so I would have 5/3. The reason I'm doing that, I just don't want that to be part of my integration by parts. Okay. So that's u dv du is simply dt, and then v is going to be negative, ooh, that is so ugly. Let me fix that. Okay, v is going to be negative 3/4 cosine 4/3 t plus 3. Okay, so that's easy enough. Then you're just going to be integrating a sine when you do the integration by parts. All right, so again, I'll trail off and let you guys, if you need to, look up an integral video on integration by parts. Okay, that's in the Calc 2 curriculum. All right, see you guys next video.